it's Carly McAvoy. I'm talking about properties of a sampling distribution of means today. When a random sample is drawn from a population with a mean of mu and a standard deviation of sigma, we have the following mean and standard deviation for the sampling distribution, and that is, we can say that the mean for the distribution of means is going to be equal to the mean for the population, that parent population that we talked about in the last video. And the standard deviation is different though. We take the standard deviation of the population and we divide by a square root of n being the number of items in our sample. So regardless of the shape of the population distribution, the shape of the sampling distribution will be approximately normal as long as you have a large enough sample size. And we looked at that in the last video as well. So here's our example. This is a normally distributed population. A person's measured glucose level 1 hour after ingesting a sugary drink varies according to the normal distribution with a mean of 125 and a standard deviation of 10. If a single glucose measurement is made, define and draw the distribution. What's the probability that a single measurement is greater than 140 milligrams per deciliter, I suppose that is. Well, that's a single. And whenever we're talking about the probability of a single, which I've bolded those two, we're just talking about using the standard deviation and the mean that is given in the problem. So we don't have to change anything for that. We want to have we have a normal distribution, we have a mean of 125, we have a standard deviation of 10. You can write it in that way. And so how are we going to find that? Well, we're going to find that using GeoGebra. So let's go to GeoGebra with a mean of 125, a standard deviation of 10, and find out what's the probability that a single measurement will be greater than 140. So to do that, I'm going to go to Classic GeoGebra, and I'm going to click on probability over here, and that's going to give me this this distribution that I can look at. And so what I want to do is put in my mean 125 and my standard deviation, which is 10, and then I'm asked what is the probability, and you can always go back and check what you're asking. What's the probability that it's greater than 140? So we're going to go in here and we're going to type in, make sure that we're looking at this side, greater than, so we're on that side of than 140. And that gives us the probability of 0.0668. So I just typed in the mean and the standard deviation, and I made sure that I could be asking, is it less than, is it greater than, is it in between these two values or on both ends? So you have to make sure you choose that correctly. Now I'm going to go back here and show you what we had on that page. We used GeoGebra to get 0.0668. And that's the picture that we saw. And what does that mean? What that means is that if you move this over 2 places to put that as a percentage, it means that 6.68%, there's a 6.68 chance that a single glucose test will be greater than 140. So that's one person. One person comes in. It could be that that one person is quite a bit different than the average. When you're looking at one thing, that can happen very often. In the second part, it says, if measurements are made on 3 different occasions and the mean result is computed, discuss each of the conditions required to use a sampling distribution for the average of the 3 results. And what we're talking about here is the central limit theorem that we talked about in the last video. And there are 3 things that we said we had to meet. 1, we wanted to know if they're independent. We have to prove that those samples are independent of one another. Well, if 3 different people come in and we choose those people, then they're definitely independent. The other thing is, are they random, which I almost said in the last one. That's a second case. They have to be random. So you're going to randomly choose 3 people, and those 3 things then are going to be independent. And then you have to say, what about the sample size? Well, the sample size here, I don't want that to look like minus, sample size is 3, and that's really small. But our population is normal, and when we have a normal population, the central limit theorem says that we don't have to worry about that size. So we're okay with having 3. So now we're going to define the sampling distribution models and its parameter. Remember from up here that the means are going to be the same, but we are going to have a different standard deviation because we have to do this, because we're really changing the standard deviation when we have a more than one thing that we're looking at. So what we're going to see is that we have 125 because that matches our last mean. And then to find the standard deviation of the means, we are going to take the standard deviation of the population and divide by our sample size, which is 3. Our standard deviation was 10, and that's how we're going to get 5.7735. And so we can look at that written in a little nicer format. We have a normal distribution, that's what that N is saying, and we have a mean and a standard deviation now that we can go and use on GeoGebra. So we're going to use GeoGebra to get 0.0047. So going back into GeoGebra, to find this, we still are talking about something normal. We're still talking about 125. We're still talking about greater than 140. But the only thing we're changing here is this value, which is 5.7735. And I think that sometimes it doesn't like that last digit to show up there. And if that happens, you can always type it in using the keyboard that actually comes with the program if that's an issue. I think you can, is it here? No, I don't know where to get that now. But anyways, if you want to use the keyboard to get that, sometimes it doesn't like that. You don't just want to leave off that last value. But notice that we get a different value here, the 0.0047. And so it's what you saw the last one, which I'll remind you by looking at this picture over here. We had not a great amount, 6% is not huge, but you can see what that looks like. And then compare that to what we're getting now with 3 samples. This is a much smaller purple area, or our probability is much smaller. Because if one person comes in, you could expect, yeah, that person could be very far off of the average. But when 3 people come in, we're going to start seeing something that's closer to the average. And if 10 people or 20 people or 30 people, they're going to get closer and closer to that exact average anyway. So it's going to change with the more people that you get. So this is what we saw in GeoGebra. We saw a very small portion of them, and that means that there's a 0.47% chance that the means of the 3 glucose tests are greater than 140. So we're going to really see that it's probably not as likely that we would get 3 people that we randomly choose that would be that far off of the average. Okay, and the last question on this video is, what is the 95th percentile for the average of the 3 results from this person? And so we're going to just use GeoGebra to do that. We want to find the 95th percentile using the mean and the standard deviation for the distribution of the means. So we're going to go back into GeoGebra. And I'm just trying to show you how to use GeoGebra. So if you already know how to do that, I'm sorry. But again, I want to do this. We have the same mean. We have this standard deviation. What I want to do is say, what would give me 95%? Whoops, 0.95. 0.95 for 125. I want to make sure that I am talking about less than, sorry, because we're talking about everything to the left. 95 percentile is 95th, 95 and less. So let me get that typed in there, sorry. I needed to click on that left value, and I needed to put in the 0.95 and my mean and standard deviation correctly to get this final answer. So this is what we get in GeoGebra when I finally entered everything correctly. So let's take a look at that. Here in our answer key, we can see that. Here it is, what it looks like. This is 95. That means that 5% of the values are on the right and 95% are on the left. And if we round that to the nearest tenth, then the 95th percentile is about 134.5 milligrams per deciliter. So you can find that very easily using GeoGebra. All right, that's it for today. I'll talk to you next time.